Question 287, this one is a merit one. It says demonstrate that the cubic y equals x cubed minus 9x squared plus 27x has no maximum or minimum points. Okay, so to do this, we are going to differentiate. And make it equal to 0. So first thing is, you can see here everything's got a common factor of 3, so we'll simplify that. And then we look at this function and we say, okay, so this is x minus 3 squared. So x equals 3. So we've got a stationary point. Now, to show that it's not a maximum or a minimum, we have to look at the second derivative. Because when we have our graph, there's 3 options. We could have a cubic like this, which means we've got a maximum there at our first stationary point and a minimum there at our second one. Or we could have, the second case would be if we had a negative cubic. So the first one's the minimum and the second one's the maximum. The third case is actually where we end up with this happening. Now this happens, this is a stationary point, but it's not a maximum and it's not a minimum. It's actually a point of inflection. Now these points of inflection happen when the second derivative is 0. So we need to show that the first and the second derivative are both 0, and that tells us we have a point of inflection. So here we go. Second derivative. Now we write it like this because we're differentiating a second time. So there's a little 2 there and a little 2 there. We take this function that we had and we differentiate it. So 3x squared, differentiate that, you get 6x minus 18. Okay, now we put in our point, x equals 3, and we can see that this equals 0. Okay, so the cubic has one stationary point at x equals 3, which is a point of inflection. Now the question didn't actually ask us to give the point, so we don't have to work out the y value for this one. But if the question had said give any stationary points, then we would have to substitute in y equals 3 cubed minus 9 times 3 squared plus 27 times 3, which is 27 minus 81 plus 81, which is 27. So the point would be 327.